Okay, so yesterday we began talking about geometric sequences and series. Just a couple things. This particular quiz, I'm hoping to have those graded and in Frontline before I leave today. I'll pass those back and we can talk about them tomorrow. But since today is Tuesday, I'm figuring next Tuesday will be when the retake will be due. You just have to have the assignment turned in. We'll have the assignment probably Thursday or Friday. I'll go ahead and let you know tomorrow. Then we'll have a quiz over this. I'll let you know all those dates as soon as I get it nailed down. The one thing I do know for sure, what's next Thursday? It's our first what?
Exam.
It's our first exam of the new grading period. So it will cover arithmetic and geometric sequences and series. So definitely something we want to go ahead and start looking ahead to. Don't forget, we're already basically halfway through January, and it's March 8th that your IA is going to be due. So I am going to be giving you some time in class later on to go ahead and not only talk with me, but have time to work on your IA in case you have any last minute questions. But please continue to work on that. And if you do have any, definitely open for tutorials. You can come in the morning or in the afternoon. But let's go ahead and continue with what we were discussing yesterday. All right, geometric sequences and series. Now, we have a different formula to find the nth term of a geometric sequence. It's going to be this right here. So u sub n, the nth term, equals u sub 1, the first term, times r, that's your common ratio. Instead of having a value that you add or subtract constantly in order to generate the sequence d, we refer to that as a common difference. This is what we're referring to as a common ratio r. This is what you consistently multiply the previous term by to generate a sequence. All right. Now, with arithmetic, you went ahead and subtracted consecutive terms. In order to find r in a geometric, you're going to divide consecutive terms. Okay, so we have all the same variables again except for r. We went through the first two examples, and I believe I went ahead and did this third one here for a few people who went ahead and stayed. I'm going to go ahead and work the problem again. So if you were here yesterday, just kind of follow along with me. A geometric sequence has a fifth term of 3. So I know the fifth term equals 3. Remember that little subscript right there? That's in. So I know that's the fifth term. And a seventh term of 0.75. So the seventh term equals 3/4. I'm going to change that to a fraction. Find the first term, which is u sub 1, the common ratio r, and the 10th term. So I want u sub 10. So in order to find that 10th term, I have to have both the first and the common ratio. So I went ahead and set about solving this using a system. I went ahead and used this nth formula that we have here. U sub n is equal to the first term times r to the n minus 1. So I went ahead and plugged in everything I knew up to this point. I know that the fifth term is equal to the first times r to the fourth. Now, where did I get that 4 from? Remember, the power in the formula is n minus 1. So why do I have 4? Remember, what term number did I set this equal to? I set it equal to the fifth term, so n equals 5. So 5 minus 1 is where the 4 came from. Now, I actually know that fifth term. I know it's 3. See, so I have myself an equation thinking I can use to solve for the first term. If I go ahead and do so, I know that the first term is equal to 3 divided by r to the fourth. Now I want to do something very similar for the other term. I know that the seventh term is equal to the first times r. Since n is 7 this time, 7 minus 1 will give me 6. Okay, I'm just using the original nth term formula for geometric sequences. Okay, solve this for the first term. So the seventh term, which we know is 3/4, divided by r to the sixth. Now, I mentioned that I went ahead and solved this as a system because you'll notice 3 divided by r to the fourth, 3/4 divided by r to the sixth, they're both equal to what? They're both equal to the first term. Even though we don't know what that is, we can now say that they are equal to each other. There we go. So I can say 3 over r to the 4th equals 3/4 over r to the 6th. Okay, so what I created for myself is a proportion. So I can go ahead and cross multiply here. So 3 times r to the 6th, that's 3r to the 6th, equals 3/4 times r. So 3/4 r to the 4th. So I'm going to do a couple of things here. First, I'm going to go ahead and divide through, because I want to go ahead and get just the r's combined. I'm going to choose to divide through by r to the 4th. So that those cancel. Do you guys remember the exponent rules when you have the same base in a fraction? What do we do with those powers? Do we add, subtract, or multiply? We subtract. I always like to think of it, if it's a fraction, subtraction. I'm a poet, I didn't know it. You want the best? Come to the West. Isn't that right, Ryan? Yeah. 3r squared equals, so now I just have 3/4. Is everybody okay with what I've done so far? Okay. Ladies at home, how are we doing? Okay, now it's just a matter of solving this. We could go ahead and divide through by 3. I'm just going to go ahead and multiply through by 1/3. So that gives me the r squared I'm looking for. 3/4 times 1/3, that's 3/12. So it would just be 1/4. Well, how would I find r from r squared? Take the square root. Now, here's the issue I have with this particular resource. Several problems on here are ambiguous. That means they can either go one of two ways. When it gets to the actual paper exams, there won't be any second guessing. They'll be very clear about what they want you to do. Because here, when I go ahead and solve for r, that would give me plus or minus 1/2. So it is very possible that you could have a common ratio that's both positive and negative, so it could actually create two different sequences. One where they're all positive, or one where it alternates positive, negative, positive, negative. Okay, now, even though this happens, for our case here, we're just going to go ahead and take the positive. Okay? We're not going to worry about the ambiguity. Okay? Just know that when it comes to the paper exams, that should not be happening. Okay? There's another problem that something happens on in just a minute. We'll get to it. Okay? But now that I have r is equal to 1/2, I can now start working backwards. I can go ahead and find what the first term is. Because remember, in order to set up this system in the first place, I went ahead and created equations that I went ahead and solved for first term. So I can plug r into either of those. It doesn't matter which one. Let's say I go ahead and plug it into this one. So I know that 3 is equal to the first term times r, well, we know that's 1/2 to the 4th. Okay, well, what's 1/2 to the 4th power? There you go. So 3 is equal to 1/16 u to the 1st. And then now we just want to go ahead and solve for that first term. So I'm just going to multiply through by 16. So it looks to me like the first term is 48. Okay, because those are going to end up canceling right there. So I've already found 2 of the 3 items they want me to right here. Okay, so I'm going to go ahead and take all this out right here. All right. I'm going to go ahead and get rid of this too. So here's what we know so far. We found the first term to be 48. We found the common ratio to be 1/2. All we want now, what is the 10th term? Okay, and for that, I'm going to go right back to the original formula that'll find me the nth term of a geometric sequence. So u sub n is equal to u sub 1 times r to the n minus 1. Okay. Well, if I'm looking for the 10th term, what's the value of n? It is 10. Remember that subscript right there, that's n, that's your 10 in this case. So the first term is 48 times r, which we found to be 1/2, okay, to the power of 10 minus 1, 9. All right, so you should end up with 48 times 1 over 512, because that's 2 to the 9th power. Now 48 over 512, that does reduce. You should be ending up with 3/32. That should be the 10th term of the sequence. Would anybody like me to put that in the calculator to show you that? Look, okay. So let's take a look. So I'm going to go ahead and take 48. Okay, 48 times control divide 1 over 2. And then I want to go ahead and raise that to the 9th power. Okay. So this is going to give me 3/32. I just went ahead and multiplied the whole thing out and then simplified it after. There we go. Questions? Okay. Let me ask you what's better, when I was doing work on the whiteboard at home or doing this on the TV? I like the TV better. I miss being able to do this. Damn. Erase it all at the same time. It takes me forever when I got that little rack. But I still think it was a good investment.
I thought you were gonna like share your screen with us and like draw on your screen. But
I don't have like an iPad or anything. I have a cheap little pad that you write on it, but it's one of those where it doesn't have a screen. You just plug it into the computer and you look at the screen while you write. It's not my favorite thing to use. I'm hoping one of these times that I can go ahead and get maybe an iPad or something, but good Lord, they're so expensive. And you know me, I go home and roll on pennies every night. That's why you get into education, it's for the money. That's a joke on port. Okay. All right. Ladies at home, how we doing? Anybody have any questions? Okay, let's look at another example. Find the number of terms. So I'm looking for n. Find the number of terms in this geometric sequence. 0.25, 0.75, 2.25. Now, first off, let's go ahead and not only show that it's geometric, but let's actually go ahead and find what the common ratio is. So I know this isn't arithmetic. I'm not going to subtract the consecutive terms. I'm going to divide them. I'm going to take a term and I'm going to divide it by the previous one. So r should equal 0.75 divided by 0.25, which should be the same as 2.25 divided by 0.75. So you should be able to consistently divide consecutive terms to get r. No matter which one you look at, what are we getting? Which is?
I have no clue.
So if you have 3/4 and you divide that by 1/4.
Just 1 minute.
3.
Damn.
So we have the common ratio 3. There we go. And we can tell from the sequence, we already know that u sub 1 is equal to 0.25. Okay. All right, now remember, here's my formula. We can go ahead and say that the nth term is equal to the first times the common ratio to the power of n minus 1. Okay. Now, we're trying to find n, right? Okay. So, this term here represents u sub n. It's the last term. See, we don't know what term number it is, but for our purposes, it's still the nth term, right? So I'm going to set my equation equal to 44,000. What do we got here? 286.75 equals, we know the first term is 0.25 times the common ratio of 3, and we have no idea what n is. We don't know what term that is, so we have to leave that as n minus 1. Okay. Now, here's the thing. Will you be able to use a calculator on the paper exams?
Yes.
Yes. So could you very easily just have the calculator solve this for you?
Perhaps.
You could. Okay, let me go ahead and show you. If I were to come over here to my scratch pad, go to menu, algebra, numerical solve. Okay. So now I'm just going to type in that equation. What was it, 44,286? Is that right?
Point something.
Okay, so 44,286.75 286.75 equals is right below the blue control button. We had 0.25 times 3 to the power of, now you have to use x instead of n, so x minus 1. Now remember, when you use numerical solve, I have to do one additional step. Can anybody remind me what that is? You have to put comma in the variable you're solving for. The comma is down here at the bottom left of your calculator, right below that button that has pi on it. Okay, so comma x, not wx. And as soon as I push enter, I'm getting 11.3691. Now, it depends on your settings. When I went ahead and did this on my calculator, it gave me the answer immediately, 12. Okay. Is anybody else getting something different? Are you guys getting a decimal or are you getting 12? You got a decimal? Because I tested this just a moment ago on my calculator and it gave me 12. So this one I'm assuming it has to be the settings. Okay. So it should be the 12th term. Okay. But let's say we don't want to go ahead and just blindly follow technology. We want to go ahead and solve this by hand. Because the n is a power, we're going to have to use something from Algebra 2. It starts with an L. What was that?
No, that's from bio.
Okay.
Wait. Ask the question again.
I got 12.
You did get 12. See, that's the thing. When I put it on my calculator, I got 12. So I'm not 100% why this is giving me a decimal. It has to be something my settings are.
What's the decimal on your?
Mine was 11.36, I believe.
Oh, so it can't. It's not rounding it either. So.
Yeah. That's weird. It should have come out to 12. I'll look into that later. But let's go ahead and solve this by hand. So the first thing I want to do is get rid of this leading term. So I'm going to divide by 0.25. Okay. So I'm going to go ahead and take the 44,286.75 divided by 0.25. And I'm getting 177,147. Let's see if there are any decimals that follow that. No. Okay, so 177,147. 177,147 is equal to 3 to the n minus 1. Well, this is an exponential equation because the power is your exponent. Your variable is the exponent. So what's the inverse of an exponential? It starts with an L.
It is a logarithm.
It is a logarithm. Do you guys remember logarithms?
Yeah.
Okay. Now remember, there were 3 parts to a logarithm. Let me go ahead and write this with a different color. So you have the base, in this case, which is 3. You have the power, and you have what we call the argument. Okay. So what I want to do is I want to take this exponential equation and I want to rewrite it as a logarithm. So I'm going to go ahead and say log, what's my base? 30 of my argument, 177,147 is equal to the power n minus 1. Because this is the way I would always teach logarithms when I had Algebra 2. If you could sum up a logarithm in one word, what would it be? Well, a log is the power that you raise the base to in order to get the argument. That's all a logarithm is. It's the power you place on the base in order to get the argument. Okay. So what I'm going to go ahead and do here now to solve for n, I'm simply going to add the 1 over. So log base 3 of 177,147 plus 1 should give me n. Is this looking familiar to you guys? I mean, I'm pretty sure it's been a while since you solved a logarithm. Okay. But you never forget, it's as easy as falling off a log. Don't worry, Ryan. Class is over. We're about to log off.
That's like the 5th or 6th one, Mr. West.
There's a lot today. So I'm hoping that you remember this and that it's not stumping anybody.
Yeah, number 7 right there.
The thing I like about logs, these problems, their bark is worse than their bite.
Dude.
If you're having trouble, just stick with it. You'll be able to get it done. Okay, so now I'm going to go ahead, I'm going to hit control. Oh, let me go ahead and erase that real fast. Let me go back over here.
Dude, how do you, like,
Okay, so I'm going to hit control. If you go ahead and hit this X squared button right here, oh, excuse me, control 10 to the X. I'm sorry, it's right next to the 1. That's your log button. And you'll notice it goes ahead and gives you a spot for both the base and your argument. So we had log base 3 of, it was 177,147. And then plus 1. And see, that way it's giving me 12. I don't know why it wasn't giving me 12 the other way. But there we go. So that is the 12th term.
got the settings in your calculator correct?
Yeah, it has to be something with the settings. I would have to go in and take a look at those.
Degrees.
Okay. All right. How are we doing? How's everybody at home doing? Do you ladies remember logarithms? Kind of, sort of? Okay. All right. Well, I'll tell you what. I've got 352. We should actually be able to finish up the notes tomorrow. So why don't we go ahead and just stop here for now, and we'll continue then.